In my kinematics tutorial, we are solving from kmziaulh book. In this time, we are trying to solve the board exam question, Cambridge IGCSE additional math 606 paper 21 June 2015. This is the question number 5. This is exercise 16.3. So the expression is given here, velocity equals to one expression is given, projectile, the velocity of the particle given. The first question, find the time at when p first comes to instantaneous rest. I already have told you several times that if it is written that instantaneous rest or momentarily at rest or even written only rest, we should consider velocity equals to 0 to get the time. Let me do that here. I'm writing in the below. This is 6th question I'm doing. So let you write 2t square minus 14t plus 12 equals to 0. We are going to solve it now. Take 2 common, 70 plus 6 equals to 0. So our turns to t square minus 70 plus 6 equals to 0. Let me do the middle term break, which is minus 60 minus t plus 6 equals to 0. Then take t common, t minus 6. Another factor is minus 1 common, t minus 6. So two factors are there. We got from here t equals to 1, another value t equals to 6. But the question is written, find the time at which p first comes to rest. So we should consider t equals to 1. So our answer is t equals to 1 second. We are not considering the 6 because it written here first comes to rest, instantaneous. So 1 is our answer of this question. Hope you understood the way we did this question. Let me move to the second question. I'm going to use this another color. Question number 2, it is written here, find an expression for the displacement of O from P from O at the t second. So velocity expression is given. To get the displacement, we needed to integrate the expression. Let me integrate t square minus 14t plus 12 dt. If we integrate, we got from here 2t cubed by 3 first part minus 14t square by 2. If you have any problem in integration, you may see my previous integral. I have done all the integration from this book in my previous tutorial. So s we got from there. So s equals to 2t cubed by 3 minus 7t square plus 12t plus c. In that stage, it is written here velocity is given, so we should consider in that case, because projected from origin O at the moment when it is at origin, so we can consider when t equals to 0, s we need to consider as a 0. So if we put this value here, s0 and t0, then you can write that expression as a when we can write here when t equals to 0, s equals to 0, therefore we can write c equals to 0 here. So our final displacement equation, s equals to 2 by 3 t cube minus 7t square plus 7t square plus 12t. And this is the second part of this question, expression for the displacement. Now next question, it is written here, find the acceleration of p when t equals to 2. So for doing acceleration, we all know that we have to do one thing, which is we need to differentiate velocity to get the acceleration expression. So let us differentiate, and if we differentiate that expression velocity, we would get from there 4t minus 14. And when t equals to 2 given, when t equals to 2, then acceleration becomes 4 into t equals to 3 written here. Let me put here 4 into 3 minus 14, which is 12 minus 14 is minus 2, and its unit is meter per second square.